All right, today we're going to talk about amino acids, and you will probably be very relieved because we are not going to do any naming today. We're only going to talk about the characteristics of an amino acid. If you remember from biology, amino acids are the building blocks of protein, so they're very, very important in all types of biology and life chemistry. So when I look at this, an amino acid actually has two pieces to it. So here you can see the acid group, which you should recognize from before when we were naming carboxylic acids a couple of days ago. And this piece over here is called an amino group. Or sometimes you'll just see it called an amine. Now, while I told you that esters are often very, very sweet smelling, like flowers and fruits, anything that has just an amine group, now once I add the acid group, it's going to be a little bit different. But if I have a compound that only has an amino group attached to it, amino groups really don't smell very good at all. They stink pretty bad. And actually, there are a couple of compounds. One is called putrescine, and one is called cadaverine. I bet you can only imagine what cadaverine smells like. And so anything that's got that amine group usually doesn't smell very good. A lot of times it's a very fishy type of smell. And so they stink. But an amino group is an integral part of an amino acid, and it's not necessarily going to smell bad when it's on here because of the other chemical characteristics that it has. And so an interesting characteristic of this amino group when it interacts with this acid group is that sometimes this hydrogen will kind of migrate its way over here, and it will come and attach itself here. And what that does is that gives this a partial positive charge and gives this a partial negative charge because of the way the electrons have rearranged themselves. This is called the Zwitterion form. Zwitterion is actually German. And it's Zwitter, if I remember my German correctly, I think it means like in the middle, or the other form, the alternate form. Okay, so Zwitterion form, and you will actually see if you have an amino acid by itself, it tends to exist in this form more than it exists in this form. Now, the key thing that we want to talk about as far as amino acids is how they react with each other, because as I already mentioned, if you remember from biology, amino acids will undergo a dehydration reaction to form proteins. And so how does that work? Well, here's one amino acid, and the amino acids are going to differ by this R group that's up here. Some amino acids are quite large, and so they may have great big huge masses of other atoms up in this molecule. I have an R here. It could be an R prime because I could be mixing a couple of different amino acids together. I just stuck an R for it for simplicity's sake. But these two amino acids do not have to be the same in order to link together. Okay, so amino group on both of them. Here's the acid group on both of them. So that's what's going to help you identify it. And then what happens is a dehydration reaction. So the OH here and the H here are going to combine, and I actually should have put water over here so that my equation is balanced. And so then what happens is that you pull that water out of there, and this carbon now attaches to this nitrogen over here, and then that forms what's called a peptide bond. Okay, so I want you to be able to see these different pieces. So right here is this piece, like that. So you can see that part of it. And I'll grab my other color here. And then this piece is right here. And you can see how that peptide bond then links them together. And you can have lots and lots and lots of these that will join together in a very, very long string to form peptides. And he does go into some more detail about amino acids and peptides. The main thing I'm wanting you to understand out of it is that this dehydration reaction is what will actually link the two of them together. Okay, so there are your amino acids.